ice was seen, or sublimated material was seen as proving that there was water ice on the planet. You've said today that you had some ice samples in Tiga, and you described how the energy differential showed that that material was ice as it was being heated up. Has Tiga shown that there's a chemical composition of ice? Has it been able to sniff the material to prove that there's H2O in that sample at this time?
We did get a small release of H2O molecules we saw in the evolved gas analyzer. The fact that it melted at 0 degrees Celsius leaves very little doubt but that it is standard water ice H2O.
So we have Peter Smith. There are still doubters out there based on the sublimation. Have we quelled those doubters at this point?
I think so, but
okay.
There's some doubters that no matter what you do, you can't quell. So
okay. And then as a follow-up to that, in terms of this sample that you're analyzing right now, will you be able to use that sample to find some of the impurities in the ice and also some of the other materials in the soil, the building blocks that was talked about this morning, the hydrogen, the carbons, or will we need to go elsewhere for that test?
We'll do both. We'll first take the sample that we have in the ovens now, and we're going to heat it up about 4 more times to different temperature ranges each time. And we're doing that to see what else we can see that's in the sample. So one way to look at it, you can say the soil is the impurity in the ice, but really in this particular case, since it was probably 99% soil and maybe just 1% ice, you could almost say the ice is the impurity in the soil. But nevertheless, we will be doing the soil analysis here, and in the future we'll be comparing our results on this sample with a well-documented surface sample, looking also at samples taken from the other trench that Peter was talking about. This particular trench is taken in the center of one of these polygons. We're now sometime in the future we'll be sampling these troughs that are separating the polygons. So we'll want to make that comparison.
Dave Perlman here.
Dave Perlman from the San Francisco Chronicle. Early on, there was a good deal of difficulty in getting anything into Tiga. And now, could you describe in some fashion how you managed to get some proportion of ice as well as soil into Tiga? Was there any difficulty in trying to move that material in such a way that you had actual water ice in Tiga that you could then manipulate, and I assume will continue manipulating it unless it all sublimates?
Well, I guess the observations were that it wasn't difficult to get the ice into Tiga because we actually didn't expect any ice in the sample that we were collecting. It was just a quick scraping of the surface, and we were intending to just analyze the soil that was right above the ice layer. But nevertheless, we did get a little bit of ice in there. What we found initially, as you may know, we had some problems with the very first sample getting it into the oven, and that was because it was delivered in the form of one big, essentially, glob of dirt, and this dirt is very cohesive and it's stuck together. We've since realized that we need to kind of sprinkle the soil onto the screen gently, and that's what we use this time, and that's what we'll use for all future deliveries. So we're not anticipating any problems in that area. I'm reasonably confident that once we work out the difficulties, whatever they may be due to why the soil won't fall out of the scoop, we'll probably be able to get a sample that's far more ice-rich than this particular one. But I'm not sure I answered all of the question. But
to follow that up, Bill, does the ice itself contribute to the clumpiness, stickiness, difficulty of getting that material into the ovens?
That's a very good question, and that's one of the things that the scientists are tossing around now. The soil has very interesting physical properties, and by studying these physical properties, we can tell something about the nature of the soil, and the clumpiness is certainly one of the more interesting of these properties. One of the hypotheses we have is that there's salt in the soils on the grain surfaces, and in which case then the ice would contribute to the clumpiness. For example, I've been told there are cities up in the north, when they get ice on the roads, they actually sprinkle salt on it to make it melt. Can't imagine why, but anyway, so clearly if you have salt in contact with ice, it melts at a lower temperature. And so what might be going on here is that we've got salt grains on the surface of the soil grains in contact with the ice, and just at that points of contact, it might be melting the ice at very low temperatures, maybe minus 30 or something like that, giving just a little bit of stickiness to it. So that's one of the hypotheses, in which case, yes, the ice is really contributing to the clumpiness.
And without trying to monopolize the business, is it possible now that you'll be able to take a hard look at some of this water ice and determine whether there are impurities in it of various kinds, whether it happens to be organic impurities or not is another question?
Well, at this particular location, we won't, if we see some of these things you might call impurities, whether they're organic molecules or whatever, we won't really be able to say whether it came from the icy part of the sample or the dirt part of the sample. Now, if we've analyzed, as we expect to, some different samples, and if an ice-rich sample has more of these impurities, then we can associate it with the ice. If the ice-rich sample has fewer of them, then we might be able to associate it with the soil part of the sample. But for one particular sample, we can't tell from which part of it the various minerals or impurities come from.
Thanks, Bill. We're going to move to Houston and a question on the telephone. Can you say your name and your organization, please?
Yes, this is Mark Carreau, and I'm a reporter for the Houston Chronicle. I had a question about the TIGA system. I think I'm counting that there's still 6 ovens left, and I wonder if you could sort of explain your strategy at this point for using them at the, I guess, at the site you're at or in the 2 trenches you plan. And could you sort of update us on the electrical short issue that arose earlier and whether that's still a threat or not a threat to using all of the ovens if you plan to?
Okay, I'll comment on the second one first just because that's the easier. We did have a short developed early on. We are reasonably confident it came from one of the solenoids that we're using to work the vibrator. We had to run the vibrator quite a bit on that very first soil to get the clumpiness to break down. And somewhere along that line, we think the vibrator overheated. Maybe some of the insulation broke down, and one of the wires touched the chassis. Turns out that short circuit has actually disappeared, probably because the wire that was touching the chassis has simply moved, whether it's due to vibrations or thermal cycling of the instrument, but whatever, that short has disappeared. That particular short wasn't much of a problem. Any event, we could still operate the remaining ovens, but right now we feel that that's not really much of a problem whatsoever. We are operating the solenoid differently now in that we're never going to operate it for more than 3 minutes at a time, followed by at least 3 minutes of cooling. This will ensure that the object does not overheat again in the future. Now, getting back to the first part of the question, maybe you better remind me what it was.
Future cells.
Oh, future cells. Thank you very much. Yes, what we do have plans laid out for the future cells. The next one is going to be a surface sample. We've already had one surface sample, but this was taken in an area where we've got good reason to believe there was a lot of mix-up with stuff thrown up from the rocket motors when we were landing. We want to go to a place right near Rosy Red to get a sample taken from essentially the same location as the one that went into the wet chemistry lab for its first sample. So that's going to be our next one. Then we'll go over to the, well, the order may be up for discussion where we go next. We might then go back to Snow White and get a higher concentration of ice sample if indeed the technique for delivering those samples has been worked out by then. Other samples we're going to do is we're going to go into the trough area